Often people come to us saying, why would I put hydronic floor heating in? It costs more, where I can just put electric floor heating in for half the price. And that's true, but let me tell you why you probably would regret it going down if you made that decision down the track. I'm Phil from Euroheat, and we've been designing and installing heating and cooling systems in Western Australia for over 30 years. And because we design and construct the systems and we keep in touch with all of the clients over the years, not only do we know in theory how it all works, but we see the results over time. So I'm going to tell you a little bit about the difference between electric and hydronic. Electric floor heating is pretty simple. There's a wire which loops around, sort of looks like this but skinnier, and it connects to a wall controller, and then the wall controller basically reads the room temperature ideally, and then also the floor temperature. And what happens is electricity passes through the wire, there's some resistance, it heats up, and so it heats the floor and that radiates out. Now the wall controller with the electric floor heating, that will say, okay, well, we haven't hit our target temperature, which is 21 degrees yet, so turn on, keep going, keep going. But then it has another sensor in the floor which says, it's getting really hot down here, because you can't really control the temperature of that heating element. So it's saying, oh, it's getting really hot, switch off. So even though the room isn't at temperature yet, the thermostat has to, or the floor heating, electric floor heating has to switch off so it doesn't overheat, be too hot for people to walk on and touch, so it doesn't crack the floor, and all sorts of other reasons. Now, that is pretty cheap to install because there's not much to it, to be honest. Someone just has to come, lay the cable, put the controller on, connect it to the power, and it's done. Whereas with hydronic floor heating, you've got this piping which carries water, and the piping and the cable, they probably cost a similar amount. That's not a huge worry. There's a little bit more time with the hydronic floor heating, but the main difference is the energy source. So with hydronic floor heating, you can use electricity like you do with the electric floor heating, but you would be using electricity to heat water, which would then flow through the pipes. But that's not a really efficient way to do it. You can use other sources like gas, which was the tradition for a long time, but now mainly heat pumps are being used, and they also use electricity, but the electricity doesn't heat the water. The electricity turns a compressor, which with a refrigeration cycle, and you can watch some of our other videos to find out about that. But the heat pump uses about 1/4, well, it uses almost all the electricity on this compressor, which then harvests the air, say from either the air or from the ground if you've got a geothermal heat pump. And so you have efficiencies of around 400, 500, 600, even 700%. And that means for every kilowatt of electricity you put in, you can get, let's say, 5 kilowatts of heat out, or 500% efficiency. Whereas with the electric floor heating, if you put in 1 kilowatt of electricity, you get 0.99 kilowatts of heat out, roughly. So that's 99% efficient. Now, what does this mean? It means that your running cost is lower with hydronic floor heating with a heat pump, because you have basically a 5-time better return on that investment. Every kilowatt hour of electricity you put in, you get 5 kilowatt hours back instead of the 0.99. Now that is on a short time scale. That's not much, that might be, the difference is, let's say if you need 1 kilowatt of electricity for your electric floor heating, which is tiny, like a tiny system, then you're going to get, you need a little bit over 1 kilowatt of electricity, which might cost you, 30 cents today if you buy it from the grid. Whereas with the same floor heating system, sure, you need 1 kilowatt of heat output, but if you're at 500% efficiency, that means you only need 200 watts, or 0.2 of a kilowatt of electrical input to get that 1 kilowatt of heat output. So that makes a difference in the running cost. So sure, there's a difference in that would be 6 cents an hour if you're paying 30 cents per kilowatt hour from the grid. So 6 cents an hour versus 30 cents an hour for that 1 kilowatt small system, tiny system. It doesn't seem like much, but obviously your house needs more than 1 kilowatt of heat, and you're running it for more than 1 hour. You're running it for a lot of hours and for a few months really. So that cost adds up, and that difference is in the thousands of dollars every year. The other difference is that we can also maximize the economy or the efficiency of the floor heating system by lowering the water temperature. And so the heat pump can, say, get even higher efficiency than that 500% if the water temperature can be, let's say, 30 or 25 degrees, which a lot of the time it can be for heating if the system is designed and installed well. So that means that your efficiency might be closer to 650 or 700%. So again, that cost saving, increases quite dramatically. So let's assume we've got a house which needs, let's say, 20 kilowatts of heat for the floor heating system. If you have a hydronic heating system, you need, with the heat pump, let's say it's working at that 500% efficiency, you need around 2 kilowatts of heat input, which means that, 4 kilowatts of heat input. My maths was a little bit off there. So that means that that's the equivalent of sort of like 2 room heaters that you would plug in that you might get from your local retailer. There's oil-filled heaters. So let's say they're 2 kilowatts each. You've got a couple of those, same amount of power, but you can heat the whole house for the same amount as you can heat 2 rooms. Now with electric floor heating, you need that whole 20 kilowatts. So with the hydronic, we only needed 4 kilowatts input to generate 20 kilowatts of heat output. With electric floor heating, if we need 20 kilowatts of heat output, we need to put in 20 kilowatts of electricity. So that is a lot of electricity. And what we find a lot of the time is that, first of all, people don't use the electric floor heating after the first billing cycle because they get a bill shock because they didn't realize it was going to chew so much electricity and that it was going to cost so much to run. But we're also finding during, say, construction or design phase of the house that people are having to upgrade their power supply from the retailer, from the energy supplier, because whatever they've been given originally isn't enough to satisfy the electric floor heating demand. So there's additional costs there. Now, sometimes I hear people say, well, it's fine, I'm going to have a solar power or solar PV system, so it's just going to run from that. But let me talk about that briefly. So first of all, when you need the heat is when the sun isn't shining usually. So in winter, it's in the mornings and in the evenings. Now, a lot of people say, oh, but I can just heat the slab and it's going to stay there and it's going to heat up. That's true to a degree. You can heat it up a bit. It is going to retain some heat. Unless you've got a really well insulated house, you are still going to lose heat. And you'll find that, let's say by 8 p.m. or maybe even a little bit earlier, that you need to turn that floor heating on again to inject some more heat into the room because the temperature's been dropping and it's sort of getting a little bit uncomfortable. So you can preheat the house, but it's only going to help for a few hours, and then you're going to need to supplement it with some more heat. The other thing is that in winter, the PV system is producing much less electricity than it is in summer. So you might have let's say a 10, or if we go on the back of the example we had before, you might have a 20 kilowatt solar system. And if you've got a 20 kilowatt electric floor heating system, well, awesome. In summer, that would work pretty well for a few hours in the day when the inverter is producing that 20 kilowatts. Now, unfortunately, in winter, we're probably, let's say where we are in Perth, you're probably getting 40% of that capacity in winter. So that means that, what are we getting? 8 kilowatts of power production in winter. And that's only probably happening for 1 hour in the middle of the day. Then on either side of that peak, we're producing much less. And that's actually where we want to heat. So you have a massive shortfall in the amount of energy that is being produced by the solar PV system in comparison to what's required by the electric floor heating system. And so this is why the additional investment in the hydronic heating system pays off most of the time. Sometimes we tell our customers we'll put in an electric floor heating system for you, and it's because it might be too costly or not big enough to justify a hydronic heating system. So if you've got a small area, and let's say around 30 square meters, if it's less than 30 square meters, look, we'd probably just recommend a electric floor heating system. Yes, the running cost is going to be a little bit higher, but because it is a small system and there's only a certain amount of energy sources certain sizes you can get off the shelf for hydronic heating, you're going to be stuck with an energy source which is sized for a bigger house and therefore costs you a lot per square meter if you were to average it out. And so before you pay that back with the running cost difference, it's going to be a long time. So in those situations, electric floor heating definitely, and also where you have isolated bathrooms. So we're actually at a project right now. Usually we put in hydronic floor heating everywhere, even if there is some isolated bathrooms. Now, for a few different reasons for this project, there's actually electric floor heating upstairs in the bathrooms. And look, that made sense on this particular project, and I would suggest that if you're looking to heat only your bathrooms, then electric floor heating is probably a good way to go, because that'll keep your capital cost down. The running cost is going to be unpleasant, but if you did a comparison, that's the better way to go. And if you're only looking to heat the bathrooms, another consideration is that you're not heating it for most of the day or evening like you would your living room or your open plan kitchen, living, dining. In the bathrooms, you're using it usually for shorter periods of time and at specific times of the day. So you might get up every day at 6:30 in the morning, so you can turn that floor heating on at 6 a.m. and have it off, let's say, at 7. So you've only got it on for an hour block in the morning, and it might be in the same in the evening, maybe with a bigger window because things change throughout the day, but it's much more manageable. So I think that is a good solution for bathroom only heating. But if you're doing, say, more than 30 square meters, then definitely hydronic floor heating, while it does cost more to install initially, will save you money on running costs and will not complicate your energy consumption or electrical energy consumption in the house. Say your power supply, your integration with your solar PV or consumption of your solar PV. So I would suggest to you that let's say 90% of the time, a hydronic floor heating system is probably the best way forwards. And the only way to know that really though is to speak to someone who has been doing it for a long time and knows what they're talking about, and is going to definitely give you the best solution for you, not the best solution for them because that's what they sell, but the best solution for you, whether it's hydronic or electric or maybe neither of them. Maybe both of them are bad options for you. If you do want some good help, please do give us a call at Euroheat. We've been designing and installing floor heating systems, amongst other things, for over 30 years, and we would love to help you too.